Today's topic is family of quadrilaters. Under that parallelogram. We have already completed quadrilaters, properties of quadrilater. Then properties of trapezium also we have done. The next one is the next type of a quadrilater is parallelogram. What is this parallelogram actually? Okay, now see, quadrilater is nothing but it is having 4 sides, 4 angles. Okay, and sum of angles is in a quadrilater is equals to 360 degrees. Similarly, when a quadrilater turns into trapezium means in a quadrilater, if one pair of opposite sides are parallel, then it becomes a trapezium. When these are parallel, some of these two are 180, some of other two angles are 180. Okay, in detail I have explained the properties of trapezium, you can check. Now from trapezium, how parallelogram turns, how a trapezium turns into parallelogram. Here only one pair of opposite sides are parallel in trapezium, whereas parallelogram means I am not drawing properly. Okay, this is one pair. Okay, one pair of opposite side are parallel, and also the another pair of opposite side are also parallel. Okay, these two are parallel and these two. Okay, now these symbols indicates that the length of two opposite sides are equal. Okay, now this is parallelogram. The properties of parallelogram is A, B, C, D. If you keep like this, whatever properties this quadrilater is having or else trapezium is having, the same properties this parallelogram will also, it follows extra properties which are one pair of opposite sides are parallel and they are equal here. Means AB is parallel to CD, AB is parallel to CD, and also AB length is equals to CD. The length of these two are equal. Means if you have 5 centimeters for AB and this is also 5 centimeters. Similarly, another pair of opposite sides are also equal. What is that? Another one, AD. AD is parallel to BC. They are parallel and they are equal. The length of their opposite sides are also equal. AD is equals to BC. Okay, this is first property. I mean, apart from the properties this quadrilater, whatever quadrilater is having, the extra one is which parallelogram follows is opposite sides are equal and they are parallel. Okay, and the second one is, okay, I told you already, when a transversal intersects two parallel lines, for example, I'll draw with a pencil. Okay, now if I extend like this, and if I extend DC also like this, so these two are parallel lines and it will become a transversal. AD will become a transversal, right? And these two are parallel, BC also a transversal. So when I explained when I was explaining trapezium, okay, if I extend these two becomes parallel and it is a transversal. One side, sum of one side of a interior angles of one side of a transversal are supplementary. These two are supplementary, means 180. Sum of these two is 180. And if I extend like this also, these two are also supplementary, but they are not parallel. Okay, A, B, C, D. AD, sum of angle A and D is angle A plus angle D is 180, and angle B plus angle C is 180. Only these two are, sum of these two are 180, whereas angle A plus angle B is not 180 in trapezium. Why? Because these two are not parallel and it is not a transversal. They are not parallel. See, somewhere they are intersecting here. Whereas in parallelogram, if you observe, these two are parallel. I mean, even these two are also parallel. Whatever properties this trapezium is having, okay, angle A, angle D is 180, angle B and angle C is 180, whereas angle A and angle B is also 180 here. Why? Because if you observe, AD is parallel to BC, right? and it is a transversal. If you rotate a diagram like this, okay, now see, these two are parallel and it is a transversal. When it is a transversal, interior angles of one side of a transversal is equals to supplementary, right? Means angle A plus angle B is 180. So in the sense, what I want to tell you is, second property, sum of two adjacent angles is equals to 180 degrees in this parallelogram. Means what? Angle A plus angle B is equals to 180. Angle A plus angle B, or else angle B plus angle C is equals to 180. You take any two adjacent angles, they are 180. Okay, angle C plus angle D is equals to 180. Angle D plus angle A is equals to 180. Okay, so this is second property. And third one is, opposite angles are equal. Opposite angles are equal in parallelogram. See, for example, if I say, where is a pencil? Okay. For example, if I say this one is 100 or else 120. Okay, this is 120. Angle C is 120. Angle C is 120. Now, what is angle B can be? Now, angle B, you need to find out angle B. Already has given angle C. So, how can you, using this property, when a transversal intersects two parallel lines, these two are parallel lines and it is a transversal. So, now, interior angles of one side of a transversal is 180, right? Or supplementary, sorry. Interior angle, sum of interior angles of one side of a transversal is supplementary. It's nothing but angle B plus angle C must be 180. So already 120 is here. So what should be the angle B here? 60 degrees. Angle B is 60 degrees. If it is 60 degrees, what is angle A? Already 60 degrees exist here. Angle A plus angle B should be 180. So this is 120. If it is 120, it is 60. So even if you calculate in this way also, opposite angles are equal or not? Yes. So in that way we can say that opposite angles are equal. Means angle A is equals to angle C and angle B is equals to angle D. Now, next, diagonals. What are the diagonals? What are the diagonals here? AC. A, B, C, D. Now, what are the diagonals? A and C, B and D. Okay. Diagonals are not equal. Okay, not equal. Who are diagonals? AC is not equals to BD. They are not equal. Okay. Next, fourth point. This one is fourth point. Fifth point, diagonals bisects each other. What do you mean by bisecting? Bisecting is nothing but they intersect at their midpoints. For example, this one is 8 centimeters. AC is 8 centimeters and BD is 10 centimeters. So they intersect at point O. Imagine they are intersecting at a point O. How they are intersecting? They are intersecting in such a way that AC's midpoint is 8 centimeters. The midpoint is 4 centimeters. And BD's midpoint is, BD length is 10 centimeters. And their midpoint is 5. So they are going to intersect at 4 and 5. Okay. In another way, I can say that they are going to intersect at their midpoints. Means O is there. OD is 5 centimeters. OB is 5 centimeters. They are going to intersect. They are going to divide. O is going to divide this BD into equal parts. Similarly, O is going to divide this AC into equal parts. 8 centimeters. So here it is 4. Here it is 4. Understood? So diagonal bisects each other is nothing but they are going to intersect at their midpoint. Okay. Now these are the points of a parallelogram. If I have missed anything, I'll explain you later. Okay. So this is about parallelogram. Thank you. Yeah. If you want, you can take the example of this. Can you see this? Yeah. Now it is a matchbox. A matchbox. I just cut it so that I can explain you. Okay. Now it becomes rectangle, right? The difference between rectangle and parallelogram is here this is rectangle, opposite sides are equal and they are parallel. Here also equal and they are parallel. I'll explain you by comparing rectangle and parallelogram in another video. Now we are trying to, we are talking about parallelogram. Now this is parallelogram, right? Now this is parallelogram. When I'm doing like this, no, I'm not changing the length of opposite sides, but something is happening. What is happening? I'm not changing the length of sides here, but here something is happening. See, if I do like this diagonal is smaller than the other diagonal, right or not? So in a parallelogram, you can see, you should imagine this diagram in your mind. So I'm doing like this. So in a parallelogram, diagonals are not equal. Okay, if one is shorter one, the other one is bigger one. Okay, so diagonals are not equal, and diagonals bisects each other, means they intersect at their midpoints. If I draw a line like this, they are going to intersect at their midpoints, means this point O is there. Okay, this O divides diagonals into equal sides, equal parts. Okay, now why I have shown this diagram means, if I talk about parallelogram, this diagram should come into your mind. So when I'm talking about parallelogram, you should know teacher was doing like this. It's nothing but diagonals are not equal. So diagonals are nothing but joining the opposite vertices, right? The line segment joining opposite vertices is nothing but a diagonal. So if I do like this diagonal length is smaller than the other one, right or not? So diagonals are not equal. Now with the same what we call paper, I'll explain the properties of even rectangle also in a next video. Okay, thank you.